in a BMW i8, hybrid electric. It has a small short-range electric battery, and that's mated with a traditional petrol engine. When the two are working together, it's reasonably high performance, quite a light car, a lot of carbon fibre, and quite interesting to drive. Cars like this are collecting enormous amounts of data every moment, every second. And that talks an awful lot to what's happening with the Internet of Things.
You know, the car essentially becomes a connected network device. Tesla's, you know, part of the service regime, or what you might call a service regime with a normal car, is literally patching the computer systems within the car. And there's a lot of speculation and controversy about how secure that is, and whether people could literally, you know, hack into these cars and cause difficulty that way. But it does throw up the requirement these days for new ways of looking at security.
I do think we have this you know, looming issue where, yes, the more responsible manufacturers are building, I don't know, connected coffee machines and connected home security cameras and everything else with a level of security built in, with thought for you know, users being able to change passwords and make them more robust. But I fear that there's a large part of the, shall we say, the more economical end of the market where that good practice is simply not happening.
The traditional security model still being used actually, is about 30 years old now, based on what was purely IT-based requirements, and we're moving away from that now. Completely new concepts like, is it possible that somebody with bad intentions could you know, cause my car to malfunction while I'm driving it at of course no more than 70 down the motorway. We're starting to come into Windsor now, so I guess we'll be able to look at the castle soon. A castle is a perfect example, actually, in a sense, of the old way of doing security, which is, you know, you'll have this really thick wall and tall wall around some sort of very often some sort of village or something, and be defended by this large wall outside. The problem is, if you had a determined attacker that can get through that wall, basically, you know, breach the wall, essentially you have a completely undefended set of citizens and people inside.
Determined attacker or subterfuge, clever attacker,
yeah.
You know, for that, read today's social engineer, who talks their way in or tricks their way in.
It's not that it isn't a valid way of defending, it's just that it's not enough on its own. You need to have additional levels of security as well, and then layering on top of that things like app defense.
With VMware App Defense, shifting the approach from looking for the bad, looking for the exception, to understand, here's the normal parameters, and looking for something that steps outside that, and then using intelligence to identify, respond, isolate, you know, take whatever particular action we need to take in order to ensure continued secure operation of a data center or of an application.
It's a disruptive way of doing security that's very different to the traditional model. So essentially we define what a steady state, uninfected environment looks like, and then we detect differences from that, rather than having to look for the bad every time.